Nikita, and I'm handling 3D printing part in IPMA's MTech. So today I'll be joining on behalf of IPMA's MTech team and making you all understand about 3D printing. And we also have our very own speaker from Sri Rapid Technology, Mr. Nitin Saudhary. So he will be talking about 3D printing, and we will make wait for more 5 minutes for others to join. Till the time, I'll just start an video on IPMA's MTech. Hope you all enjoy it. Thank you. Okay. So thank you so much for watching. So Nitin, so we will go live and you can
Okay.
just start right now.
Do you want me to start a video also from my side?
Yes, please, sir. Okay, perfect.
Yes.
Hello, Nitin sir.
Yes,
May
good
I hear?
afternoon, madam.
Good afternoon. How are you doing?
I'm fine, I'm fine.
Yeah. Thanks for joining and
Little busy, just came yesterday from abroad, so yes.
oh,
I hope I don't get the calls. Yeah, please.
yeah.
Yes, sir.
Then
We are live and we can start the presentation now.
Okay,
Yeah,
okay.
thank you.
So good afternoon, everyone. My name is Nitin Chaudhary. I am from Shri Rapid Technologies, one of the partner of Shri Rapid Technologies. And today we will start the presentation about the webinar on the 3D printing. So can you see my screen now?
Yes, sir.
Okay. So this webinar is brought to you by Shri Rapid Technologies and the IPMA Institute, which is one of the premium institute or the for all the plastic manufacturer association, and they are taking a key role in pushing the advanced manufacturing technology like 3D printing into the market. So little background about Shri Rapid Technologies. Shri Rapid Technologies started in 2007 by myself and my partner, Mr. Shashidhar Kumar. And before starting Shri Rapid, we had almost 10 years of experience in 3D printing. So our journey with 3D printing actually started in 1997. And we started Shri Rapid Technologies after almost 10 years of experience in 3D printing. And we offer the complete digital manufacturing solution, end-to-end solutions for the industry, starting with reverse engineering, scanning, then software required to convert the reverse engineering software, reverse engineering part into the CAD model and printing that part into various different technologies using our 3D printing technologies. So we also have one of the customer innovation center, one of the unique in India by any manufacturer. So at one place in our facility in Andheri, you can see all the plastic 3D printing as well as metal 3D printing technologies uh, for experience to the customers, as well as do benchmark, as well as do the proof of concept. So our presence is almost in all verticals of industry, starting with defense, aerospace, medical, dental, general engineering, automotive, nuclear power, consumer goods, education, as well as we are also in a very big in jewelry industry. Our head office is based in Mumbai, with our branch office in Delhi and Bangalore. We have close to 95 people now all over India, and our majority of our employees or our workforce is in application and service support for these technologies, which is very, very critical for these technologies. And we have by now almost close to 600 plus machine installed for various 3D printing technologies. And some of the brands we represent, 3D System, one of the leading and the pioneer company in 3D printing. 3D Ceram is a ceramic 3D printing company. BCN 3D is basically desktop FDM printers, and BMF is high resolution SLA technology. This is micro SLA technology. Then we have other technologies like Formlab and GOM and JICE for the different 3D printing as well as reverse engineering technologies. We also represent Atomic, Zotrax, and Minecraft, which are different 3D printing technologies with different kind of. So we also represent Dimension, which is a post-processing technology for after doing the printing of the part. You can post-process and finish the part. So there are some companies which are critical in this field. So introduction, what I want to give is basically the 3D printing for the people who are not aware about 3D printing is basically we convert CAD model into 3D object by depositing material layer by layer. So sometimes we deposit, sometimes we laser cure, or sometimes we actually do it by printing. So different way of doing it. So traditionally, we use for plastic, but now it is also used for composite, ceramic, as well as metals. So we are able to do all the three type of technologies now. And also 3D printing has improved the manufacturing process and supply chain. So a lot of people are using 3D printed part as a spare part supply or urgent part supply also. And definitely it helps to save the cost, reduce time to market, as well as you can integrate with traditional and digital manufacturing processes. So some of the advantages of 3D printing is you can make just-in-time manufacturing, so you don't need to keep any dies and molds. You also very quick in design and production, as well as some modification of the designs. Then also you can minimize the wastage, strong, and you can make lightweight part. Basically, this is being done by topology optimization. There are a lot of softwares available where you can actually optimize the weight of the part without compromising the load carrying capacity or the stress carrying capacity of the part. So a lot of work being happening in India and abroad in this particular field, and this especially applies to plastic as well as metal. So we have very the applications what we are able to do in aerospace, and especially the space, and the a different kind of so lightweight manufacturing applications are coming up. Even in some of the applications are in what you say, the electronics manufacturing, especially the chip manufacturing, semiconductor manufacturing. A lot of machines components are being made using 3D printing. And advantages limited. As we have advantages, we also have some of the limitations. We have low volume production. We cannot go very high volume. For mass production of the parts, I think still the conventional technologies still hold good. We have a restricted on the build size. We cannot make very large piece, more than 500 by 500 millimeter. So we are limited in the part size. Of course, the investment for 3D printing for the production machines, initial investment is very high. And the advantage is that you don't need actually very skilled labor, but you need the people skilled on 3D printing. So, the lack of 3D printing skilled labor is one of the bottleneck what the companies are facing today. So I am saying this as a problem, but it also is an opportunity for the new generation to get immediately get trained on 3D printing and accustomed to these technologies, and there will be a lot of job opportunities. So what are the different technologies available? So stereolithography is the technology where we use a liquid resin, and with the help of laser, we cure and we make a solid part. As you can see in the video, the part is built from a liquid bath and is coming out of the bath after the part is complete. So this is completely unattended, and this is why this is the mother technology of all 3D printing, because this was the first 3D printing technology which was launched. And the STL interface or STL file, what we call nowadays in 3D printing, is actually coming from this stereolithography. So STL was the interface developed for the first 3D printing machine in the world, which was stereolithography. That's why the file still is called as stereolithography. Then the next step is also DLP, is digital light processing. So here, in contrast with SLA, we do completely one layer at a time by projection. So in stereolithography, we use laser beam to actually draw the part in analog way. In DLP, we actually project the whole layer at a time in a pixel, in a digital way. So it's a faster technology compared to SLA, but then because of the way the curing is taking place, and because of the DLP technology limitations, we cannot go beyond certain limit of the size of the part. So DLP is basically depending upon the projector, the DLP projector. And now there is also a parallel technology coming to DLP. It's called LCD. So instead of DLP, people are using LCD as a light source, and there they can make bigger parts. The third biggest technology in 3D printing is selective laser sintering, which is also from 3D systems. And this is called SLS. Like stereolithography is called SLA, digital light processing is called DLP, SLS is selective laser sintering. Here, we actually make parts from a polyamide nylon powder by melting the powder using the laser beam. So like in SLA and DLP, we use liquid resin as a raw material. In SLS, we use the plastic powder as a raw material. So that is the biggest advantage of this technology. And in SLS, because we use plastic powder as a raw material, it doesn't need any supports. So the SLS is basically, because we are making part directly from a polyamide powder, the parts are actually made from polyamide. So the parts are almost strong or as strong as you can say injection molded part, and that is why wherever you need functional prototyping, people use SLS technology. So fourth technology is multi-jet printing. So multi-jet printing is basically called MJP or MJM, multi-jet modeling. This technology was trademarked and patented by 3D Systems in 1990s. And as the name says, is actually 3D printing technology, because we use a print head to deposit the part. So we already inside the machine has a Xerox company print head, which actually prints and deposits the material on the platform. So actually, initially the people were calling 3D printing or additive technologies as a rapid prototyping. But when we actually launched the multi-jet printing with the 3D print head, the technology started calling as 3D printing. So the name 3D printing is coming from this technology, because we actually started using printing as a print head for the printing. So that is what is called 3D printing. So accordingly, we can discuss what is the origin of this technology. And just a minute. Then we have the fused filament fabrication, and that is the technology which is everybody is aware of, used for desktop printing, which is basically using the ABS or nylon or PLA wire, hitting the wire and depositing. So we represent a brand called BCN3D from Spain, which is actually used for printing this. And we can make, we have a dual extruder printer where we can actually make plastic part using this printer. So here we can use also carbon fiber based materials. Nowadays also different kind of composite materials are available, and in this material we can use and we can make functional prototypes also. But the fused filament fabrication has a limitation because of the speed and the accuracy and the resolution what we can get using the triple F fused filament fabrication technology. And the last technology is the direct metal printing. So direct metal printing is similar to plastic sintering. Instead of plastic powder, we use metal powder, and we use laser beam to melt the metal powder to make part layer by layer. So here on this screen, you can see the major technologies which are available in the market and which are actually leading the field. But even today, if you take from me in the plastic, SLA and SLS are the two technologies which are still leading the industry. And then there are some markets or there are some applications where DLP or multi-jet printing technology is becoming famous. So if you see, all these technologies use some kind of depositing method or some kind of curing or some kind of fusing medium and some kind of material. So in SLA and DLP, we use liquid resin. In SLS, we use plastic powder. In direct metal printing, we use metal powder. And fused filament, we use plastic wire or plastic filament, and for deposition. So we have actually agenda to develop our know-how and generate a manpower for future requirement use for additive manufacturing. And we have now, so the figure is a little old, we have 600 plus installations now. We have decades of experience. We have highly trained engineers in-house in service, application, as well as in sales. And we have the state-of-the-art 3D printing center here in our facility with almost 18 different type of 3D printing systems. I'm not talking about desktop printing, I'm talking about production printers. So anybody want to come and get exposure, they are welcome, and we can do that. So actually, we are also can be partnered. We are actually partnering with IPMA, IMTech for bridging the gap between 3D printing job requirement and in industry through education, through our expertise. and we are committed to impart the knowledge and help and develop the skill for the 3D printing industry. As well as IPMA has designed a courses for 3D printing, where we also participate along with our people and we contribute, and also the same way we can also actually have a job opportunities in our own company as well as in our customer places for such trained people. So what are the roles involved in 3D printing and what are the opportunities for people are in 3D printing? Is basically, there is a lot of these multinationals and a lot of corporates are now started recruiting additive design engineer or DFAM engineers. So a lot of conventionally manufactured parts, now people have started realizing if we can actually use 3D printing technology or additive manufacturing technology to justify and whether we can get advantage in any design for functioning as well as design for manufacturing applications. So at the same time, we have opportunities for application engineers, where application engineer's job is basically to train people on 3D printing, to explain the customer application of 3D printing technologies, how this is different than the conventional technologies, and what are the advantages compared to the conventional technologies. Then we have additive manufacturing engineers, basically who is actually running the machines, who is running the processes using additive 3D printers. Then we have printing technician and operating managers. So there are operators using 3D printing machines, and there are service engineers, because when there are so many 3D printers sold in the market, there will be a lot of requirement for people who can do servicing of these machines, maintenance contract of these machines, calibration of these machines. So all these technologies are required into the, all these roles are required as the technology is getting more and more established into the market. So this technology is Zotrax, is a desktop printer other than BCN3D, which we represent. So it's a Polish company, and we have this printer installed at IPMA MTech facility, where the first exposure to a desktop 3D printing can be done. So people who are completely new with the 3D printing, I suggest them to first go through this basic course of 3D printing along with Zotrax, and where we can have a fairly good amount of build volume of 8" by 8" by 6", and we can make a very good quality part using different kind of PLA, ABS, or glass fiber or the carbon fiber based materials. And it's a very good technology for people to understand how layer by layer a part is manufactured. So this basic course consists of introduction to the traditional manufacturing and how you are actually, of course, different technology of 3D printing, like I showed you. So it can be a STEM program for all, and it's a 20 hours course at IPMA MTech, and we have also trained their trainers, so their faculties are trained also with this kind of courses. And here you can also get some hands-on software knowledge. You can also do 1 or 2 part building if it's possible, but basically there is a theory, there is an exam, there is a practical on the Zotrax printer. So also there is a little bit of introduction to the next level of 3D printing technology, that is figure 4. So this is a very good course, and I would say any novice or any person who has a inquisitive to what is 3D printing, they should do this course, and this will help them to get accustomed to the whole technology and understand how it is different conventional to the compared to the conventional technologies. So 3D Systems is the company we represent on a broader way. This is a company in 1986. They launched the first 3D printing technology, that is SLA, and then they have the broadest range of 3D printing technologies, starting from SLA, SLS, multi-jet, DLP, metal, and now also coming up with direct plastic extrusion. There are a lot of new technologies which is coming up, including the bioprinters. So this is the only or maybe unique company in the world today, 3D System, which is a pioneer company in 3D printing, who has actually able to offer you the complete range of 3D printing technologies. The advantage is that we know advantages and disadvantages of each technology. So we are able to guide a right technology for right application by the customer. So that's always a possible. So 3D System is the pioneer company in 3D printing. So they have the broadest range of R&D in all these type of technologies. And I'm very proud to say that most of the industry segments, most of these 3D printing product segments, 3D system is the leading technology in the market today in terms of accuracy, in terms of finish, in terms of technology, in terms of application, in terms of materials, in terms of software capabilities. So this company is always a very forward looking, and you can say industry trendsetter company in terms of 3D printing. So this is another technology, DLP, that's called Figure 4 Standalone. It's we always call that as a digital alternative to injection molding, because the parts which we can make on Figure 4 Standalone are almost having the same quality like the parts from injection molding. And we are also even able to get a good amount of injection molding properties. So that is why we are talking about now. We have a solution to make 3D print the plastic parts for low volume production or same day production or a same day prototyping. So depends upon the application. So it has a volume of 128 by 70 by 196. And we have another model with 300 millimeter, 350 millimeter. And this technology is a very high speed technology. We are able to do almost 50 to 60 mm per hour. The build height, which is the very high speed. And this is again, the technology at the core of this is DLP, but it's basically a very advanced DLP technology by which we are able to make almost production quality parts. So here you can see how does it work. So we have built platform which is moving up, and the part is built upside down, and there is a liquid resin placed over a liquid film membrane and a projector at the bottom. So a bottom projector projects the complete layer at a time, and each layer the platform moves up and it goes on building the part layer by layer. Okay, so the advantage of this material technology is that you don't need to have a lot of material in store for the machine. Even with 1 kg bottle of material, you can start building the parts. So that gives the advantage that you can try different materials very quickly without much investment. And we have close to 30 different materials available on this technology, starting with biocompatible, starting with high temperature, rubber-like, transparent, black-like, white, ABS-like, or PP-like materials, and that gives a really good exposure to the various kind of application what we can do with a very small investment. So this machine is in the range of 25 to 30 lakhs, but it gives an application and it can build parts like injection molded. So if there are some listeners to this webinar who are from the injection molding industry, who make very small and or medium sized parts and a very complicated part, this is the right technology for you to try to make part within hours. I mean, I can tell you 100 mm, 150 mm part is done in 2 to 3 hours time, and you can actually get part when you are out for lunch, and you can see the part in your hand, which is almost like a molded quality. So that's a great advantage this technology gives. So this machine is also installed at IPMA, and I request every plastic company, manufacturer, or R&D or development team should have a look at this technology and try to build a 3D system technician course. It's an advanced course, and this is with the help of a Figure 4 machine. And we have part building experience, we have designing experience for supports, we have different printing technology, we have different material properties experience. So all those things we can train, and also we give some experience on how we finish the part, secondary processing. So it's basically a very good course for 60 to 70 hours. It's an advanced course, and I advise you people to at least attend after the basic course is completed. Then you can go ahead with this course. And you can see the number of companies trying to adopt additive manufacturing, and in India also a lot of companies are going towards adopting the technologies already all the automotive and auto ancillaries, they are using 3D printing. But there is also a lot of opportunity for businessmen who want to start business in 3D printing. There is a very good opportunity for job shop using 3D printing technologies, and that is one of the biggest advantage what I can tell you. So what IPMA MTech can offer is basically a hands-on training, visit to industry who is using 3D printing, and you become industry ready with 3D printing certificate course or a 3D printing course under your belt, so that you can be ready with the job where we can get a placement for job opportunity. People are looking for job in 3D printing. So, sorry, yeah. Yeah. So this is the little background about 3D printing technologies. So if there is any question and answer, please let me know, and then we can discuss. Otherwise, I think we have discussed a lot on the job opportunities, and I think there are so many job opportunities in the 3D printing market. Every day we are looking for good people in 3D printing for sales, application, service. So I think we need completely different mindset of people to get into additive manufacturing, because this is opening up a completely new way of manufacturing. And now I understand also 3D printing has spread into the civil, I mean the for the construction industry, for doing the cement concrete 3D printing for the houses and the buildings. So that area is opened up. So I think the additive manufacturing and 3D printing has really opened up the minds of the people that what we can do with the additive by adding. So there are a lot of metal cladding technology coming up in the market, direct metal deposition technology coming in the market. So 6 or 7 technologies only I showed, but there are at least another 10 technologies which are coming up. There is a binder jet technology which is now coming up very fast in the market. So people are basically started adopting layer by layer manufacturing, and then they started to do how we can do this layer by layer manufacturing and where we can do. So I think in future there will be a lot of new technology, a lot of new way of 3D printing is going to come. There are a lot of people are trying to now combine a 5-axis milling machine with the 3D printing head. So you are able to deposit the material in 5-axis in 5 different angles, and you are able to make completely free form geometry. So that's one of the great way of depositing. So a lot of things are coming up, a lot of new ways of are coming up. So that's it from my side at present. So if you have any question answers, we are ready to answer the question. Thank you. Yes, Nikita, you can take over.
Thank you, sir. Samir, can you please help me with it?
Yeah.
Okay, so as IPMA's MTech, all the courses are now NSDC approved. So we are a partner of NSDC. That means all the certificates will have an NSDC and Skill Development Corporation logo on it. So that means it comes under government. And hope that whosoever who are interested in the courses that we are offering over here in IPMA's MTech, they will actually avail this opportunity and enjoy this certified courses. Can we please change the slide?
Yes. Just say next. I'll do that.
Yeah, so well, as I said that it's a good opportunity for a good education, is a foundation for a better future, as rightly put by Sameer, I'll say. And so the thing is that IPMA's MTech are basically giving both the courses, the DLP technology and the Zotrax, that is FDM technology. And we are also giving internship opportunities if people who are interested, also for students industry visits, so that they understand more about 3D printing. and enjoy basically enjoy this course with us and understand more about this rather than having an syllabus kind of a thing. We would like students who want to enroll, or even the industry people who are more interested in knowing what is 3D printing. So this is a great opportunity for them. So I think that's about it, and I'll ask Ratnakar to unmute people if they have any question answers, or they can also write it in the chat. Before the question answer starts, I would like to actually personally like to thank Mr. Anup Ghosh. He's from IIT, and he's a professor with us for FIPS, packaging, plastic and packaging courses. And we are very glad so that you are here today attending our courses. Thank you so much.
Thank you.
So we are open now for question and answers. You all can please ask questions if you all are, want to know more about it. Thank you.
Can you hear me, Nikita?
Yes, sir, I can.
Can you hear me?
Yes, we can.
Yeah. See, thank you. But I'm really interested. I do work on this. So thank you for arranging this seminar.
Thank you so much, sir, for attending.
Applications.
Okay, any question answers regarding this? Please, you all can answer.
Who can help in 3D printing industry is a very good idea.
Thank you so much, sir.
I would like to know what are the materials that have been tried in this by Mr. Nitin. Are they do only supply? Are they already tried different material, and what are those materials?
Well, we actually on a stereolithography machine we have epoxy resin, so like ABS, PP like materials. On figure 4 we have all kind of photocurable resins.
Okay. In layer by layer, is the temperature is any limit?
The temperature for what? For part withstanding or how?
In a layer by layer where the filament fusion has to happen, I think is in your machine temperature is no limit. If I go for high temperature melting or high melting temperature polymer or composite.
No, we have a limitation of 150, 200 degrees depending upon some of the print heads. The machine what they have, Samir, how much the temperature? What on a Zotrax? We can go 150. 290. But 300. So there are some machines available with fused deposition modeling even with 500 degree temperature. But we are not talking much. That's only for the concept clear modeling. But when you go into mass production or when you go into production 3D printing, then we use SLS. There we have 200 degrees, 180 degrees temperature capacity.
Okay.
For the material.
Okay. I don't know whether you know. I mean, when you do that FFF, what is called fused filament fabrication, is a polymer amorphous or crystalline and all that? Does it make? We have to be very selective about polymers.
No, basically we use filament made from ABS, PC, PETG,
nylon,
nylon,
PLA.
CF, nylon carbon fiber, mixed filament also.
Yeah, but if you want to do polypropylene, simple polypropylene, it's difficult because it is crystalline. And
Even now the polypropylene is available.
3D
Yeah,
printable
but
polypropylene.
you cannot compare the properties like injection molded from FFF. FFF is basically, you can say, is for concept modeling for some moderate amount of functional trials. So you cannot compare with the injection molded microstructure of the plastic.
Lastly, do you supply machine, or you take different projects to give for
No,
different,
we
or you
supply.
can?
The major business is supply the machines and the technology, and we
Okay.
have also developed applications along with the customers.
Yeah,
And
yeah, that's what I meant. Yeah. So
yeah,
if a customer is interested, you may be able to provide your platform to develop some products and.
yeah, I mean, yes. Also, we tell them if they want some job work to be done, then if they want to buy a machine, we may do some initial job work. Otherwise, basically, we do we do the forward the customers to our job shop people who are using
Sure,
our
sure.
technologies.
Sure, sure, sure. Okay, okay. I just wanted to know because many people come to us also some developmental work and all that. We are developing facilities even in IIT now to Delhi to develop many machines.
We are also working with IIT in different departments.
IIT Bombay.
Yeah, IIT Bombay, yes.
Yeah, yeah. Good, good, good.
In IIT Delhi, we are given machines. In IIT Hyderabad, we are given machines. So
Okay,
actually, we work a lot with students. I like to work, and we are also partner with IIT Delhi's one team with Formula Car team, and
okay, okay.
we were one of their partner for building parts. So there was one question whether we provide help towards printing the parts for student projects. We can definitely work, and we can try to offer some support depending upon the size of the project. So it's
Yeah,
not
yeah,
that
yeah,
we can do
yeah,
everything free, but depending upon the project size and project application,
yeah,
we can decide about
yeah,
the cost, but we can do it at
yeah,
no cost basis. I
yeah.
mean,
Are you
no profit
maybe
basis, no
you're
profit
working
basis
with
also.
PBM Rao, no?
Sorry.
You may be working with PBM Rao or something.
Actually, my colleague is handling that, so I don't know exactly
Okay, okay.
because I'm not
Fine, I'll
directly
be in
involved
touch.
in the
We
sales.
we can be in touch. We can be in touch. Thank you.
You're from which department, sir?
Thank you. Thank I'm in the material science.
Acha, material science. Okay, okay,
Yeah, yeah,
okay.
yeah.
So you can share your details. We can be in touch. No issues, sir.
Sure, sure, sure. You can let me.
Okay.
Thank you. Thank you.
So we provide support to the student projects. We also sometimes accept
Yeah,
interns
that's a
depending
good
upon
thing.
the
That's a good thing.
duration. We
Yeah.
also accept interns in our company, and we have also we offer trainees. I mean graduate engineering trainees for the 3D printing.
Yeah.
So time to time we have vacancies also.
Yeah. Yeah. Thank you.
Thank you, sir.
Thank you
Thank
very
you.
much.
Any other question?
Attendees, you're free to ask the questions. Unmute and you can ask your questions.
Machines provided like apart from FDM or SLA, what other machines are provided by Sri Rapid Technologies?
SLS, DLP, figure 4 I showed you. Then direct metal printing, direct metal printers we have bio printer, we have micro SLA, then we have multi-jet printer for wax printing as well as for the resin printing. So I think almost all type of technologies which are available, we are in a position to offer most of this. And we have all these machines at our display in our facility, and we can build parts, we can show the parts to you. If you want to do some projects, we can do.
Thank you.
Any more questions? You all can just unmute and you can ask. If you are shy to unmute and ask the questions, you can also write it in the chat. We are okay with it. We can answer all your questions. I think Miss Nivedita Patil, she asked me a question that all these certificates are, all these technologies that we are offering in IPMA's MTech, are they certified or not? So I would like to answer it that yes, they are certified. And as I mentioned that now it is certified and you are also be getting an Skill India NSDC development logo on it. So that would also help. Anything else? Okay. I think then we'll wrap up.
Yes.
Okay. I don't want Nitin sir also. I know that he is in very busy schedule.
No
Thank you
issues. I
so
think
much.
we have answered all the questions, and I think everybody is satisfied. So I think we can now conclude this. So thank you
Yes.
very much, everybody. And anybody needs any information, they can write to us or IPMA and
Yes.
get more details or visit anytime IPMA as well as SRT. Okay.
Yes.
Thank you very much. Thank you. Bye bye.
Thank you so much. Thank you.
Bye.
Bye, sir. Thank you. Thank you, everyone. Thank you.